talk about types of chemical reactions. We are responsible for 5 different types of chemical reactions. I have them listed out here. I have examples of each, and I'm going to tell you how to identify each of them. So the first type of chemical reaction we're going to talk about is a synthesis reaction. A synthesis reaction is when you have multiple reactants and they become one product. So you have to realize first is where your reactants are and where your products are. Everything on the left side of this reaction arrow, a reaction arrow will be in every single reaction. These are our reactants. They are the things that react in our reaction. Everything to the right-hand side of our reaction arrow are our products. So here we have hydrogen and oxygen that are reacting together and form water as our one product. Let's see if that makes that any better. Okay, perfect. So multiple reactants becoming one product is a synthesis reaction. Our next type of reaction is decomposition, and it's actually the exact opposite. We have one reactant that breaks down into multiple products. So we have a more complicated reactant that breaks down into simplified products. That is a decomposition reaction. It's decomposing. Okay. Then we have a single replacement reaction. So for a single replacement reaction, we're going to notice that our reactants have one element and one compound. Remember, an element is just a single type of atom, and a compound is multiple types of atoms put together. So what happens in a single replacement reaction, the element that is by itself will kick out one of the ions in the compound. So here, sodium is kicking silver out. So silver now becomes the element that's by itself, and sodium gets paired up with chlorine. So single replacement reaction, you have an element paired with a compound on your reactant side, and on your product side, you have a new compound and a new element. Our next type is a double replacement reaction. So a double replacement reaction we can identify because we have 2 compounds in our reactant side. What happens in a double replacement reaction is our cations switch places to form 2 new products. So on our reactant side, sodium is paired up with sulfate, but on our product side, sodium is now paired up with chlorine. Same thing here, silver was paired with chlorine, and now silver is paired with sulfate. Our last type of reaction is a combustion reaction, and combustion reaction is always a similar type of formula. It is a hydrocarbon. A hydrocarbon is something that contains hydrogen, carbon, and sometimes oxygen. Okay, but a hydrocarbon will always react with oxygen, and it will always form carbon dioxide and water. So combustion reaction, you just have to be able to recognize the compounds that are reacting and being produced in order to see a combustion reaction. You need to know those 5 different types. Next that we're going to talk about is balancing chemical reactions. So in order to understand why we balance chemical reactions, we want to look at the law of conservation of mass. The law of conservation of mass tells us that matter cannot be created nor destroyed. So basically what that's telling us is if we start off with a certain number of each atom on our reactant side, we have to end with that same number on our product side. So I'm going to zoom in a little bit here just to make sure you can see it all. Let's see, .cam, zoom in. Okay, that should be good. All right, so on our reactant side, notice how we have 2 hydrogen atoms. And on our product side, we have 2 hydrogen atoms. So hydrogen was not created nor destroyed, but you have the same amount of each atom on both sides. Now we go to oxygen. We have 2 oxygen atoms on our reactant side, but we only have 1 on our product side. So what we're going to do is we are going to insert coefficients. So coefficients are numbers that go in front of individual particles. A particle is either an element or a compound. So because I have 2 oxygens on my reactant side and only 1 on my product side, I can put a 2 coefficient out in front of water. So now my oxygens, I have 2 on this side, and now this coefficient will apply to that oxygen, and now I have 2 oxygens. But when I put this 2 here, I changed the number of hydrogens I had. So originally I had 2 hydrogens, but this 2 is telling me that I now have 2 waters. So if I add up all of the hydrogens for my waters, I now have 4. So I have to go back and rebalance. So I had 2 hydrogens on my reactant side, but I need 4, so I put a 2 out in front of H2. So now I double check. I have 4 hydrogens. I have 2 oxygens. Now on my product side, I have 4 hydrogens, and I have 2 oxygens. So I'm balanced. I'm obeying the law of conservation of mass. So you're going to follow this kind of pattern every single time you're balancing. I always start from my left and work my way right, and if I change a coefficient, I go back and fix whatever else it affected. So here, magnesium. I have 1 magnesium on my reactant side, but I have 3 on my product side. So I need 3 on my reactant side. Next one I have is hydrogen. I have 3 hydrogens on my reactant side, but I have 2 on my product side. So I have to make them even. And the way that I do this is through least common multiples. So I know that I'm doing multiplication here, right? Because I'm multiplying a coefficient by a subscript. So the least common multiple between 3 and 2 is 6. So in order to get 3 to 6, I need to put a 2 out in front of here, and I need a 3 out in front of here. So now, 3 times 2 is 6 hydrogens on my product side, and 2 times 3 is going to be 6 hydrogens on my reactant side. Next up is nitrogen. I now have 2 nitrogens on my reactant side because that 2 coefficient, and then I look on my product side and I have 2 nitrogens on my product side. So I'm balanced. You can always double check if you'd like. So I have 3 Mg on my reactant side. I have 6 H's on my reactant side, and I have 2 nitrogens on my reactant side. We just want to make sure it's equal. So again, I have 3 magnesiums, I have 2 nitrogens, and I have 6 hydrogens. All right, next up. If you see any polyatomic ions on both your reactant and product side, I would put them into parentheses so you keep them together. Okay? So I have 1 aluminum on my reactant side and 1 aluminum on my product side. So aluminums are fine. Now I have 1 phosphate ion on my reactant side, and I have 1 phosphate ion on my product side. So PO4 is fine. Here I have 1 lithium on my reactant side, but I notice I have 3 on my product side. So I need to put a 3 out in front of lithium chloride. Next up, I have now 3 chlorines because I put that 3 out in front of lithium chloride. And on my product side, I also have 3 chlorines. So I am balanced, I am good to go. Last is a combustion reaction. So what I do when I do combustion is I start off similarly. So I have 3 carbons on my reactant side, and I only have 1 on my product side. So I need to put a 3 out in front of carbon dioxide. Next up, I have 4 hydrogens on my reactant side, and I have 2 on my product side. So in order to get this to be 8, because 8 is the least common multiple between 2 and 8, I need a 4 out in front of water. Now this one is a little bit different because the next one that we have to balance is oxygen, and that is in 3 of the compounds. So what I do next, so first I balance my carbons, then I balance my hydrogens. Third, I add oxygens on product side. Okay, so from carbon dioxide, I have 6 oxygens, and from water, I have 4 oxygens. So I have a total of 10 oxygens. Well, oxygen is only part of O2 here, so the least common multiple between 10 and 2 is 10, so I need to put a 5 out in front of O2 in order to balance it.